AND gate. An AND gate has two or more input and one output. The output Y is 1 only when input A and B are both 1. Logic symbol for AND gate is shown in figure. This is the logic symbol for AND gate. Here this represent input A and B, and this is the output Y equals to A and B. It is read as A and B. Now Boolean expression for AND gate is Y equals to A and B, or A and B, Y equals A and B. Now third table. The third table for AND gate is shown in the here. This is the A input and this is the B input and this is the output A and B or A dot B. When input is 0 or low, A input is 0 or low, or B input is 0 or low, Y output is low. That is input is 0 means low and output is high. Then again we have output low. When input is high, that is 1, and input B is low, that is 0, then again output is 0. When both input A and B is high, then we get output as high. Then it means that in AND gate only one is obtained when both input is 1 1, or both input is at high, then we get high. Now switching operation for AND gate. This is shown switching operation. This is switch S1 and this is switch S2. That it represent input A and it represent input B, and this is the bulb which gives output Y equal to A and B. Here see, when switch S1 is in off state, that is 0, and S2 is in off state, there is no light in the bulb, so we get no light, no output. Similarly, when S1 is off and S2 is on, again we get no light. This is the off state. Or you may also ask that when S1 is low, S2 is low, output is low. When S1 is low and output is high, we get output as low. When S1 is on, that is at a high, and S2 is off, that is at low, again we get output as low, that is no light. Again S1 is on or S2 is on, that is S1 and S2 both, that is input A and B, both are at high, then we get high as output. That is when S1 is 1 and S2 is 1, output is also 1, and that is high. Now this is the circuit diagram to represent AND gate or AND gate circuit. Now NAND gate. NAND gate means NAND gate, not AND. That is, it is AND gate followed by NOT gate. The output is not 1 when both input are 1, that is at a high. It is also known as universal gate because we can realize other gates using this gate. This is the symbol for NAND gate. Here AND gate is followed by NOT gate. That is, this is the construction of NAND gate, and we get A into B, and finally this is the input A, this is B, and finally we get Y into A dot B bar. Now logic symbol of NAND gate is represented this. This is the original logic symbol of NAND gate. Here input A is, this is the input B, and here we put a circle on the head of AND gate, and it will convert into NAND gate, and Y equals to A dot B bar, or A NAND B, as we can ask also. Now third table for NAND gate. For example, when A is 0, 0 means low, and 1 means high. So I don't. It should be in your mind that 0 represent low, and 1 represent high. Voltage or current, anything. So when input A is 0 and input B is 0, then we get A dot B, that is A and B equals to 0, 9, but NAND, that is Y equal to A dot B bar, will be 1, that is opposite to 0. Bar represent opposite to A dot B. Here again, A is equal to 0, B is equal to 1, and A dot B equals to 0. So NAND, output of NAND gate will be 1. Again here A equal to 1, B equal to 0, and A dot B equal to 0. So A dot B bar will be 1. Here again 1, 1, 1, and A dot B also 1, and so uh, this will be 0. So in NAND gate, now it can be represented by switching operation. This represent input A, and this represent input B, S1, S2, and this is the output of NAND gate, Y equals to A dot B bar. Now see from the example here, that is S1 is off, that is 0, and S2 is off, then both are 0. Then we get no light, that is 0. A dot B will be 0, but Y here output will be light, that is 1, because this switch is off, this switch is off, then current flow like from this, and light is bulb is lighted. Again switch S1 is on 0 state, that is off. S2 is S1 is off, S1 is off, and S2 is on, that is the switch is on, and A dot B will be no light, so here will be light. Again S1 is on, that is it is on, and S2 is off. Again we get no light, A dot B equal to no light, so here will be the output of NAND gate will be light, that is 1. Then both switch is on, that is like this, both switch now made on. Then current will pass through this, and so A dot will be 1, and so output, final output, that is NAND output of NAND gate will be no light, that is 0. So this is the switches operation for NAND gate. Now NOR gate. NOR gate, not OR. It has 2 or more input and 1 output. A NOT operation applies after OR gate gives NOR gate. Its output is 1 only when both inputs A and B are 0. Now we can make the not gate, NOR gate, applying. If we apply NOT gate after OR gate, this is the OR gate, and we have applied OR gate after OR gate. So this combination will give NOR gate, and its formula will be y equal to a plus b bar, and the final logic symbol of NOR gate is this is the logic symbol. So this is the final logic symbol. Here input is A and B, and OR gate is if we remove this circle, then it represents OR gate. When we put this circle, then this is the symbol for NOR gate, and the final output will be y equals to a plus b bar. That is opposite of a plus b, inverse of a plus b. Now third table of NOR gate. Here we have to get this represent the NOR gate, and this represent OR gate. So when both input is 0, our output is 1. Here input is 0, input is 1, A input is 0 and B input is 1, then output is 0. A input is 1, B input is 0, then output is 0. A input is 1, B input is 1, then output is 0. So in NOR gate, output is only 1 when both input is 0. That is, output is high when only when both input is low, or in another case it is always at low or 0. Now switching operation for NOR gate. This represent figure the switching operation for NOR gate. Here the switch, this is switch S1 and this is switch S2. S1 is represented by input A, S2 is represented by input B. This is the output y equals to a plus b bar. Now see one by one. When switch S1 is on, off, and both are off, A and B switch are off, then we get light here, and so because both are on, so A plus will be 0. So y, that is A plus b bar, this is the output of our NOR gate, so will be light 1. In another cases it will be 0, output will be 0. For example, switch, if we make on, if S1 is off and S2 is on, the current will pass through this and no bulb will be not lighted. So final output is no light, that is 0. Again, S1 is on. Now S1 has on, so current will be passed, and this is off. So current will pass through this, and no light will be here. So output will be output of NOR gate will be no light. Similarly, when both switch is on, that is S1 and S2 both are on, like this switch is on, this is on, then whole current will be passed through this and there will be no light, so no light. So in case of NOR gate, only we get output when both the input are at low.